So let's move on in our notebook here to positional encoding. And I'm just going to show you where that diagram in the slide came from here. So we're doing this the hard way, if you will. We're going to hand code our own positional encoding function here. And you can see it's nothing special. It's actually quite straightforward. So we have here a function that says encode positions. It takes in a given number of tokens, a given depth, how many layers deep we want to go, and how many values we want to generate going across. So we start off by filling our matrix with zeros in a num tokens by depth array. And then for each one of those tokens, we take the range up to the depth divided by 2. Why are we doing that? Well, that's because we're interleaving both a sine wave and a cosine wave into this positional matrix. So half of the values are going to be from a sine wave, half are going to be from a cosine wave. And we apply this function that turns it into, what the academic paper says it should be for positional encoding. But let's go ahead and define that function. And then when we run it, we can visualize that using matplotlib. So all we're doing here is saying I want to encode up to 50 tokens with a depth of 256. And let's plot that in 2 dimensions. And it looks like this. So you can see that sort of banded pattern indicating that interleaved pattern between sine and cosine. So, you can kind of see where those different sine and cosine waves are alternating here. And, beyond around 125 or so, we start to lose some information at this depth. But the general idea, again, to refresh your memory with positional encoding, is that since we're processing all of these words in parallel, we need to have some sort of idea of where each word stands relative to the other words around it. So you can imagine this sine wave continuing on, and then eventually it will loop back up, right? So there's going to be a period to it. But in this case, that period is so big that we're probably not going to hit it at any practical limit. So based on where we are on this curve for both sine and cosine, we can estimate where inside the input this particular token lives. And that's how positional encoding works. That's how our transformers know where a given token is within a given sentence or within a given paragraph, whatever it might be.